This towering structure isn't a building, it's the engine of the world's largest LNG-powered container ship.
It's so massive that workers can easily walk around inside it, like exploring a mechanical labyrinth. This colossal engine drives a propeller as tall as a two-story house through the ocean.
At startup alone, this ship consumes between 100 to 200,000 liters of fuel.
Incredibly, its fuel tank could hold 6 Olympic swimming pools worth of liquefied natural gas.
Today, we explore a mega project that has pushed the absolute boundaries of human engineering capability.
Welcome to this deep dive into how 10,000 workers build $200 million ships. Even in our digital age, 90% of international trade still travels across the seas. At any moment, flight trackers show 15 to 20,000 aircraft in our skies worldwide.
But marine trackers reveal 308,000 cargo ships sailing the oceans right now.
We've built massive ships, but even larger vessels cannot pass through critical canals anymore.
Major waterways like Panama and Suez limit how big modern container ships can actually grow.
Now the competition isn't about building bigger ships, but creating more fuel-efficient vessels instead.
French shipping giant CMA CGM aimed to build the world's largest eco-friendly container fleet.
These revolutionary ships would run entirely on liquefied natural gas instead of traditional oil.
This 400-meter ship stretches as long as 4 complete football fields placed end-to-end.
It's 1 meters wide and stands taller than India's historic Qutub Minar monument itself.
Its weight equals 7 Eiffel Towers, or 11,500 African elephants combined together.
This ship can carry 23,112 containers in a single voyage.
If lined up end-to-end, these containers would stretch 150 kilometers down the road. CMA CGM committed to building 9 of these giants in just 24 months total.
A 4-kilometer Hong Kong shipyard, resembling a small city, was chosen for this project.
6,000 workers from around the world worked day and night in coordinated shifts.
Each worker had a specific, specialized role, requiring years of training and experience.
Normally, one ship takes 18 months. How could they build 9 in 2 years?
The answer was revolutionary block construction, building sections separately, then assembling them together.
The foundation required 12,660 anti-corrosion steel sheets for construction.
Cutting used laser beams at 18,000 degrees Celsius, 3 times the sun's surface temperature.
880 kilometers of steel strips were precisely cut and joined together. These blocks ranged from room size to multiple stories, with systems already installed inside. The ship's stern consisted of 5 blocks weighing 790 tons combined together.
2 giant cranes worked together lifting this massive section with millimeter precision required.
A single millimeter error in placement could ruin months of work and delay everything.
Welding totaled 1,250 kilometers, equivalent to Karachi to Lahore distance in Pakistan.
Every single weld was meticulously inspected because ocean waves show no mercy to weak spots.
The real achievement was designing an engine to run on LNG instead of traditional oil.
This meant 99% less sulfur dioxide and 91% reduction in air pollution. It also produced 20% less carbon dioxide making shipping significantly more environmentally friendly. The challenge was storing LNG at minus 161 degrees Celsius constantly. If insulation failed, the gas would rapidly expand and cause a catastrophic explosion. The ship needed sufficient fuel capacity to travel from Asia to Europe without refueling.
This required building the largest LNG fuel tank ever created, 18,000 cubic meters.
It holds 20 million liters, equivalent to 6 Olympic-sized swimming pools completely filled. Creating this giant thermos flask inside the ship took 9 months of intensive work.
Multiple layers of specialized insulation protect the frozen fuel from outside heat constantly.
Rigorous leak testing used soap, water, and vacuum pressure to ensure absolute airtight integrity.
Any leaks detected were immediately marked and repaired before proceeding to next construction phase.
A final 1.2 millimeter thin steel membrane was installed to contact the frozen LNG.
Its wavy design allows expansion and contraction with temperature changes without cracking or failing.
This same technology is used in space stations for handling cryogenic fuels in orbit.
After 8 months, the world's largest marine thermos flask was complete and ready.
The engine stands 20 meters tall, equivalent to a complete 6-story building.
Weighing 2,000 tons, this beast generates 85,000 horsepower of pure thrust.
The engine is so large, workers can walk through its interior for maintenance access.
Transporting this monster to the shipyard required splitting it into 6 separate pieces.
The crankshaft alone weighs 220 tons, the heart of this mechanical giant.
A 140-wheeled remote-controlled platform moved it with millimeter-accurate positioning.
Installation required perfect millimeter precision to ensure smooth operation at high speeds. The engine contains 12 pistons, each 1 meter in diameter, working in perfect synchronization.
The 92-ton propeller stands 10 meters tall, a masterpiece of marine engineering.
The propeller shaft must be perfectly straight to avoid dangerous vibrations at high RPM.
Blue dye testing checks contact between shaft and propeller, revealing any imperfect fit areas.
This identifies exact contact points, allowing technicians to make precise adjustments for perfect fitting.
Once structure was complete, painting protected it from corrosive saltwater and marine growth. Saltwater and friction constantly attack steel, consuming material and increasing fuel consumption dramatically.
1 million liters of specialized marine paint were applied across the ship's surfaces.
Coverage exceeded 950,000 square meters, double Vatican City's entire area. The final block was the command bridge, the technological brain controlling this floating city. Smart Eyes system provides complete 360-degree vision from the bridge command center.
After 1.5 years intensive work, the Jacques Saadé was ready for trials.
15 days of intensive sea trials tested speed, brakes, navigation, and every critical system. Each anchor chain link weighs 300 kilograms. The entire chain equals 60 elephants.
All trials succeeded. 9 ships were built in record time, an unprecedented achievement. This isn't just about steel and technology. It's about human intelligence and dedication.
These ships now rule the seas sustainably. When humans commit, we move mountains of steel.